Yeah, welcome to our ATHENA webinar today. My name is Philipp Schwab and I work at CAD-PLAN as a technical marketing manager here in Frankfurt am Main, Germany. Yeah, what is the webinar topic today? The topic is ATHENA 2024 Quick to 3D Sheet Metal Construction. Do you want to know how you can implement your sheet metal construction projects faster, more accurately and more efficiently? I will show you our powerful ATHENA 3D functionality in a practical example. So in this case, in this topic. Okay, so then we start in the webinar. So it takes 10 seconds. Thanks for watching and we see us at the webinar presentation. So then we start in the webinar ATHENA 2024 3D sheet metal construction, and I will show you today example sheet metal construction entrance portal, and I will show you how to use the ATHENA 3D technology. So your benefits: optimal use of ATHENA functionality, time and cost savings, faster planning processes because of the 3D ATHENA technology, and minimization of errors because you have the possibility to create part lists, single part drawings and manufacturing files. And then I will start the ATHENA presentation. You will see here an ATHENA 2D section, as you are surely accustomed to in your planning. Using ATHENA 2D functionality, I have created a substructure of the sheet metal construction in the example sheet metal construction entrance portal, including ATHENA sheet metal cross sections and fasteners with sealing. I will now show you how with just a few clicks you can convert these ATHENA objects in the section into an ATHENA 3D construction. I have already prepared an axis model of the construction. With the ATHENA analysis of the axis model, you can completely analyze a line model in just a few seconds, including the weather side. You can now place bar assemblies on the axis model. These can be created quickly. You can quickly learn how to do this yourself, for example in our e-learning. In this webinar presentation, I created the substructure for the sheet metal construction. The ATHENA bar assemblies, which we can of course evaluate later, can be applied to the axis model with a single operation. And as you can see, ATHENA functionality saves a lot of time in creating a 3D model. We now want to cut the profiles. To do this, you can use the bar joint function. That means first miter cutting the corner areas of the construction. You can see that you do not have to manual miter cut the profiles using AutoCAD functions. ATHENA does it for you in seconds. Then the remaining profile joints, and ATHENA does not override any cuttings, but we define the cutting and simply cross the 3D model, and this is also done with a few clicks. All done, and the results looks very good. So that we can later mount the sheet metal panels, we need notches on the vertical profiles of the substructure and on the upper side. You can create these with an ATHENA extrusion that you can assign to the bar. I have created such an extrusion and I will show you how to edit that extrusion to a profile. With the arrangement editor, you can simply assign the extrusion to the profile for notching, as in this case. Then you can easily transfer the parameters and the extrusion object to all other profiles with one click. Here again, you can save a lot of working time thanks to ATHENA automation. So 8 objects changed, and yeah, we will look at the result together and see that ATHENA has inserted all notches at the desired nodes of the construction. And we have needed only a few steps to do this. I repeat that I'm showing you the workflow of the ATHENA 3D functionality, how to proceed from a 2D section to a 3D model with evaluations. And now I will show you how to insert infill panels into the model. You see that I have created a sheet metal infill panel with the infill manager of ATHENA, and we will now generate it on the sheet metal construction. In ATHENA 2024 you have the option of applying special infill objects such as insulating glass, other special infill types, or as in the example here, sheet metal panels to a 3D construction even faster. You can generate these objects per 3D plane in the model. So use ATHENA functionality to edit panels. You do not have to do this process manually in the 3D model, but use the apply process to infill function. ATHENA recognizes the geometry of the filling, and we define the drill holes on each side, 25 millimeters on each side in the respective corners. And we are now assign this process step by step. Yeah, once defined for the infill, you can apply the machining to all the other infill multiple times. And here too we look at the result. All the machinings or processes are now set for all the sheet metal panels in the design in a few seconds. So to complete the design, we now want to create the fastener objects. I have created self-tapping screws as an assembly group at the node point so that the screws can be inserted directly into the drilled holes. Here you can see that ATHENA assigned the assembly group at the node point in just a few seconds. For later evaluation, we can simply evaluate the screws, and you can of course deliver the model in a high level of detail if the client requires it. For example, in the BIM process. As you can see, the screws are now being added at the profile. And our sheet metal substructure with panels, processings and fastener is now ready for evaluation. You can see, of course, that the upper corners of the substructure are not yet covered with corner panels. The front and the back of the construction are also still missing, and I've prepared these parts and would like to show them to you in the next webinar so that we can complete the construction together. So I hide the parts again using the AutoCAD layer control, and now I show you the complete evaluation of the model. You not only want to simply create a 3D model, but also to be able to evaluate all parts up to export to the processing or manufacturing machine. And for this we use the ATHENA project browser to position the substructure, profiles and the sheet metal panels. This gives you a complete overview of the construction, in example, the individual parts. Everything is registered. However, we would also like to include the remaining parts in the evaluation. So now the sheet metal objects are also positioned at the front and back of the entrance and the corner panels. You can of course access the properties of each individual part at any time so that you can quickly provide informations in the later manufacturing process, or if parts are damaged later on the construction site. So now I just enter the project name I chose for the construction. Normally you do this at the beginning, but it's also possible to do this afterwards. The project name is then of course on the part lists, just in case there are no misunderstandings later in the part lists or other documents. That's why it was important to me to correct that again. We can do the entire evaluation with one or two small settings. So now we can generate the part lists for the substructure profiles. So the definition of the profiles are well set up, but you can of course add designations if you wish that. With one click you now have the part list for the construction, and all the properties for manufacturing are listed, such as quantity, tag number, item number, the label number, length and the cutting length, for example. You can see that here. And in the same step we do this with the screws. One click and all the screws are in a part list. Of course, in more complex construction there could be several different assemblies or fasteners. In this case, as an example, only the self-tapping screws that we used. So here we can look at the result. We do the same for the fillings or sheet metal panels. In this case, it does not matter which filling you have generated. Of course, you can also define the information in the part lists. In example, exactly informations you need later in the part lists. ATHENA recognizes it directly, and as in this example, you can evaluate it as a part list. So in this step for evaluation, of course, everything is also fully automatic. Here, to use the valuable working time and minimize errors during manufacturing, a great benefit for you. You can you see ATHENA automatically label and dimension the individual part drawing of the substructure as well as the sheet metal panel with processing at the push of a button, including of course the edge table and properties such as plain and white. You see all the informations you need created automatically for you by ATHENA. Of course, you also need manufacturing files of the model. You can export SAT, SLAB files, but also special EloCAD or CamQuix files directly to your manufacturing machine. This means that at the click of a button you can obtain manufacturing data to start manufacturing immediately. Of course, you also save a lot of working time and benefit from ATHENA automation, from design to manufacturing in a few clicks. At the end, I displayed the complete construction with the building structure once more. You can see that you can create the complete 3D construction quickly and intuitively and precisely in ATHENA 3D as well as evaluations. So, and now we are at the end of the webinar presentation, and I will present you our CAD-PLAN e-learning platform. You can scan the QR code here on the presentation slide. And what's your benefits of our CAD-PLAN e-learning? Flexible, self-paced learning, plan your learning to fit your needs, expert content of highest quality directly here from Frankfurt, Germany. Our experts will provide you with exercises in ATHENA and our other products, Apollon, for example. And of course, the official certificates for professional development. Yeah, you can scan the QR code, and then I switch to the next slide. Yeah, please ask me if you have questions of our topic today, ATHENA 2024 sheet metal construction in 3D. Please ask me questions to me, Philipp Schwab, directly to my email address webinar@cad-plan.com, and you can scan also here the QR code. You come to our social media platform. You can follow us on LinkedIn. You can follow us on our YouTube platform, and of course our homepage. Yeah, and now I quit the webinar. Thanks for watching. We see us at the next webinar with the next topic, and I wish you a good day and a good time. So see us at the next webinar. Thank you.